In this video, I'm going to prove 7 properties of the cross product. If U, V, and W are vectors in R3 and C is any scalar, then we're going to prove these 7 properties. And we're going to do this using the definition of cross product. So let me put it up here. And let's talk about the way I like to use this. So X is going to be X1i plus X2j plus X3k. Same for Y. This is the second component of X2. Of X, sorry. This is the third component of X, and this is the first component of X. So down here, say X is the first vector and Y is the second. So it's the first vector, second term, third term. Then it'll be the first vector, the third term, which will be X3. Their k component. Then the second vector, second term, that's in the I direction. And then the first vector, third component, second vector, first component, minus first vector, first component, second vector, third component. Same mess down here. Okay. So now we want to look at U cross V. You're going to prove A. U cross V, well, that's the first vector and that's the second. It's the first vector, second component. I'm reading up here. It's the second vector, third component, minus the first vector, third component, second vector, second component. That's in the I direction. And then you get the first vector, U, third component, second vector, first component, minus the first vector, first component, or the second vector, third component. That's in the J direction. And then lastly, the K direction. The first vector, first component, U1. Then the second vector, second component, minus the first vector, second component, second vector, first component. Okay, now so we have that's U cross V. Now if I factor out a minus sign, remember if you have A minus B and you want to put a minus sign in front of it, then A minus B becomes B minus A. So I'm going to switch that order. It's going to be U3V2 minus U2V3. And this is in the I direction, plus I factor out the minus from there. It is all the way in the front. And I get U1V3 minus U3V1J. And then I factor out the minus from here. And I get U2V1 minus U1V2. And this is in the K direction. And if you noticed, what's in those brackets is just V cross U. That is, we proved the first fact. U cross V is equal to negative V cross U. Okay, let us now do the second one. The proof of B. We want to show that U cross V plus W is U cross V plus U cross W. And let me have the definition right here. So it's one vector cross this vector. Now I agree that V and W are two vectors, but when you add them, and you want to, you can think of it as one vector. Remember, this one vector is V1 plus W1 in the I direction, plus V2 plus W2 in the j direction plus v3 plus w3 in the k direction. So we're going to think of this as one vector, and according to the definition, it's the first vector second component, which is u2, times the second vector third component. Well, that's v3 plus w3, and then it's going to be minus u3 times v2 plus w2, and this here is in the I direction, and then we add on the j directions, first vector third component. Well, that's u3 times y1, which is the second vector first component, minus first vector first component, that's u1, times the second vector third component. And this is in the j direction. And then we add on in the k direction. First vector first component, second vector second component, v2 plus w2, minus first vector second component, that's u sub 2, times the second vector first component. Okay, so there is the left-hand side, but let's do a little bit more work with it. First, let me erase this, please. Okay, so now let's distribute the u's, but let's only distribute them to the v first. So you have u2 v3 minus u3 v2, and this is in the I direction, plus u3 v1 minus u1 v3, that's in the j direction, plus u1 v sub 2 minus u2 v1, and that's in the k direction. Now let's add on and say green the w's. You have u2 w3 minus u3 w2 in the I direction, plus u3 w1 minus u1 w3 in the j direction, plus u1 w2 minus u2 w1 in the k direction. But it turns out what's in yellow by definition is u cross v. Plus, now if you notice, all the u's are exactly this, oops, that should be a u. All the u's are exactly the same subscript and all, but v became w, v3 w3, v2 w2, v1 w1. All that changed was u became w. So what's in green, instead of u cross v, it'll be u cross w. And letter B is proven. Let us look at letter C. U plus V cross W. U plus V cross W. I want to see something. Okay, well, I want to write down B and C. And then we want to look at them a little bit closer. Okay. Let us look at them over here. Okay. Now, let us play a little game with this one. Now, if I were to switch the order, W cross U plus V, let me have this out of the way so I can see what I want to do. So now, if I switch the order of this, that is V plus W cross U, well then I should get U cross V plus U cross W negated. Okay, negated. Why? Because of rule number letter A. It says that if you switch the order of U and V, put up in a cross product, you get negative. So then this will be, it'll be negative that, but negative that is just V cross U, plus negative of that is just W cross U. So what we have is that V plus W cross U is equal to V cross U plus W cross U. Is V cross U, plus W cross U. You can distribute. Let me try that again. I blew it. V plus W cross U. You basically just distribute. Okay, so now this one here, well, we just learned what to do. This is UW plus VW, which is exactly, U cross W plus V cross W. Because you just are allowed to distribute. And that came from part B. Okay, so C, I claim, is done. Now what's D asking? Okay, D. The proof of letter D. C times U cross V. Well, this is equal to C times, now I think I copied something different. Let us bring down that definition. Okay, so that is going to equal to C times, now U cross V is U2V3 minus U3V2 in the I direction, plus U3V1 minus U1V3 in the J direction, plus U1V2 minus U2V1, U2V1, and that's in the K direction. Now this one is pretty simple, but it's just a lot of silliness. This is equal to, so now I can distribute the C. This is equal to C times U2V3 minus U3V2 in the I direction, plus C times this, U3V1 minus U1V3 in the J direction, plus C times this, U1V2 minus V2V1 in the K direction. But now I can distribute the C across the subtraction. I get C times U2V3 minus C times U3V2 in the I direction, plus C times U3V1 minus C times U1V3. This is in the J direction, plus C times U1V2 minus C times U2V1, and that is in the K direction. Okay, now we are multiplying three numbers, 1, 2, 3. It's always three numbers. Remember, C is a scalar, and so are U1, U2, U3, V1, V2, V3. So one thing I have is associative law. I can multiply the C and the U2 first, times V3, minus the C and the U3 first, times V2, plus CU, CU3 times V1 minus CU1 V3, and this is in the J direction, plus C times U1 V2 minus C times U2, C times U2 times V1, and this is in the K direction. But now if we think of this as one vector, that is those three components as one vector, that this is just CU cross V. Okay, we have that. But you know what? When it comes to multiplying, let's go up to this line. When it comes to multiplying those three, I can multiply the U2 by the result of C and V3 minus the U3 times the result of V times C times V2, and that's in the I direction. Same game over here. I can go U3 times CV1 minus U1 times CV3, and that's in the J direction. And then I can do U1 times CV2 minus U2 times CV1, and that's in the K direction. Well, it turns out that what's in green is just U cross CV. So the C you can put any place you want. We proved that. You can get to be this, you can get it to be that, and you can keep it like it initially was, which was C times U cross V. That is letter D. Let's go on to letter E. Let's see what that one is. I think that's here. So letter E is we cross U with itself. Okay, so letter E. U cross U, by definition, is going to be U2, U3 minus U3, U2 in the I direction. Plus, it's going to be U3, V1 minus U1, V3. Sorry, U and V are the same. U1, U3, that's in the J direction, plus it's going to be U1, U2 minus U2, U1. But if you look, those are the same. You subtract them, you get 0. Remember, multiplication commutes. These are real numbers, they're not vectors. Okay, so we get 0i plus 0j plus 0k, which is the 0 vector in R3. So that's letter E. Okay, 0 cross W, the proof of F. We want to show that 0 cross W is the same as W cross 0, which is the same as the 0 vector in R3. Okay. So, by definition, 0 cross W. Now, remember, 0 in R3, this is 0 in R3, this is 0i plus 0j plus 0k. That's the name of the vector 1, the name of the vector 2, and the name of the vector 3. That's the first component, that's the second, it's just 0. It's just 0. So you have 0 times W3 minus 0 times W2, that's in the I direction, plus 0 times W1, 0 times W1 minus anything in, remember the X is now the O, anything in the O vector is 0 times the second and the third. The second vector, third position. That's J, plus the first component of the left vector plus the second component of the right vector. Left, right, first, second, whatever. Minus x2 is 0 times y1. Well, this is 0 minus 0. It's 0i plus 0 minus 0 is 0j plus 0 minus 0 is 0k. So this is the 0 vector in R3. Now, W cross 0, I also have to, so far I showed that this is equal to the 0 vector. Well, W cross 0 is almost the same as 0 cross W. It just has a negative or a minus 1 in front. But we just computed 0 cross W. We got 0i plus 0j plus 0k. And negative 1 times 0 is 0 in the I direction. Negative 1 times 0 is 0 in the j direction. And again, 0 in the k direction. That is, I get the 0 vector in R3. Okay, so in fact, this is also 0. This is 0. That one's 0. Therefore, they're equal to one another. Now we go on to letter G, I guess. That one is a little bit harder. So let's copy it, bring it on down, and prove it. Letter G. We want to compute U cross V cross W. Now, V cross W is a vector. You just have to figure out what vector it is first. And then we cross it with U. Okay, so it's U cross whatever vector V plus W. And that vector is, using our definition over here, it is V2W3 minus V3W2 in the I direction plus V3W1. Let's get rid of that bracket. V3W1 minus V1W3 in the j direction plus U1, see what that was. One, two. This was this, U2 V1. So then it becomes U1 V1 W2 minus V2 W1 in the k direction. Now, when it comes to V cross W, that's the first component. That's the I component. It is what it is. This here is the second component, and that there is the third component. So we're going to be using that a lot in the definition. So what we have is that this is equal to U dot this vector. But again, what is that? What is U dot that? Well, by definition, it's the first vector second component, which is U2, times the second vector third component. The third component is V1 W2 minus V2 W1 minus U3, first vector third component, times the second vector second component. That's the second component. So it's V3 W1 minus V1 W3. And that's the I component. Let us add on the J component. It's the first vector third component times the second vector first component, which is that. V2 W3 minus V3 W2 minus first vector first component, why that's U1, times the second vector third component, which is that again. V1 W2 minus V2 W1. And that is in the J direction of U cross V cross W. Let us find the K component. First vector first component, which is U1. Second vector second component, which that's the second component. V3 W1 minus V1 W3 minus the first vector second component, which is U2, times the second vector first component, which is that one. V2 W3 minus V3 W2. And this mess is in the K direction. Okay. Now, let us distribute this and then the U3. So you have U2 V1 W2 minus U2 V2 W1 minus U3 V3 W1, negative times the negative is plus, U3 V1 W3. And all of this is in the I direction, plus the J direction. Distribute their U3. U3 V2 W3 minus U3 V3 W2. Then minus U1 V1 W2 minus, plus U1 V2 W1. That's in the J direction. Plus, distribute their U1. Get U1 V3 W1 minus U1 V1 W3. Then distribute the negative U2 V2 W3 plus U2 V3 W2. And this is in the K direction. And this sum is equal to U cross V cross W. So we want to hold on to this. Okay, now let us compute what that is. Let us compute U dot W times vector V minus U dot V times vector W. Now, U dot W, that's U1 W1 plus U2 W2 plus U3 W3 times vector V. But V is V1I plus V2J plus V3K minus U dot V, that's U1 V1 plus U2 V2 plus U3 V3 times vector W, which is W1I plus W2J plus W3K. Now, this is one real number, and it gets distributed to each of these three. Well, let's find out the I's first. So, you're going to have this times V1 plus this times V1 plus this times V1, all in the I direction. So you're going to have U1, and I'm going to put it in alphabetical order, only because it's in alphabetical order here. UVW, 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 every one of them. So it's U1, V1, W1, plus, now this one, U2, V1, W2, plus the U3, V1, W3. So I dealt with that. You know what? While we're at it, let's take away what we have here for the I's. So I multiply those. I get U1, V1, W1 plus, and then I distribute there, U2, V2, W2 plus U3, V3, W3. And all of this is in the I direction. Now we add the J's. I multiply each of these three with V2J now. And I'll put the V in the middle. So you get U1, V2, W1 plus U2, V2, W2 plus U3, V2, W3. Those are in the I direction minus J direction, excuse me. Now I'll distribute each of these to, we already dealt with W1I. I'll distribute to W2J. So it's minus U1, V1, W2 plus U1, U2, excuse me, V2, W2 plus U3, V3, W2. And this mess is in the J direction. The second component. Plus, now I distribute these same three, but this time to V3K. So I get U1, V3, W1 plus U2, V3, W2 plus U3, V3, W3. And then I take away, well, I already have the takeaway sign. I multiply each of these three terms with W3. And I get U1, V1, W3 plus U2, V2, W3 plus U3, V3, W3. And this is all in the K direction. Now, let's just see if anything canceled out from this bottom. This and this are the same. When you subtract, they cancel out. This and this are exactly the same. When you subtract, they cancel out. And likewise, those cancel out. So, what we have left here is equal to U dot W, U dot W times V minus U dot V times W. And we want to know if it equals this. Okay, well, let us check. This here in the I direction, this has U2, V1, W2. And that's right here. So those are the same. Minus, I'm just going to call it 221. Minus 221. Well, I don't know why I don't have this. We'll have to look to see why. Just give me a moment, please. This here should be a 1. And this here should be a 1. Okay, so let's see if we do have the 2, 2, 1. We want to take away 2, 2, 1. Got it. I have this one. What about take away 3, 3, 1? Ooh, got it. Glad I fixed that. And I have to add 3, 1, 3. 3, 1, 3. Got it. Oh, the I's were exactly the same. How come this one didn't get, okay, now it's crossed out. It matched with this one. Let's see if the J matches. We have 3, 2, 3. Which is right here. We have take away 3, 3, 2. Ooh, 3, 3, 2. So I put them in order. We have to take away 1, 1, 2. Ooh, got it. And we have to take away, add 1, 2, 1. Ooh, got it. Hey, the J's match. There's nothing that wasn't crossed out in this entire row. Now to the K's. 1, 3, 1. Ooh, got it. I have to take away 1, 1, 3. Ooh, there it is. I have to take away 2, 2, 3. Got it. And I have to add 2, 3, 2. Got it. They're equal. These two are equal. No question about it. We proved it. Therefore, U cross V cross W is equal to U dot W times V minus U dot V times vector W. And that completes this long video. Please subscribe to my channel if you like long videos like this, proving mathematical theorems. Many of my videos are a bit shorter than this, most are. Subscribe to my channel, check it out more. Tell your friends and family about it, leave comments. Most of all, watch and learn.